Okay, on to question 3. Fractions. We've got 1 and 5/6 divided by 3/4. Okay, so first of all, let's just have a wee quick revision of our fraction rules. Okay, so adding fractions. 1/2 plus 2/2 gives me 3/2. Nice and straightforward. Okay, we can add them because the denominators are the same. Okay, 1/2 plus 2/3, we couldn't just add them together. And some people also would say 3/5, which is definitely wrong. Okay, but we couldn't just add these together because the denominator is not the same. Okay, it's like apples and oranges. Okay, if the denominator is the same, we can add them together. So how do we fix that? Well, we do a smile and a cross. So we do the smile, we times the bottom to give us, that'd be 6, 3 times 2, and then we do cross. 3 times 1 is 3, 2 times 2 is 4, and then we can add them. Okay, that'd be 7/6 or 1 and a 6. Okay, so adding with a denominator, that's the easiest one. Smile on a cross if we don't have a common denominator. The other thing we need to know how to do is to multiply, and the multiplication is the easiest one. If we've got, say, 3/4 times 5/6, that's just 3 times 5 divided by 4 times 6. 24, that is, not 29. Okay, so we multiply the top line and then multiply the bottom line. Easy. Now, this question is a division question, which you could argue is one of the more complicated ones, and they've made it a wee bit more complicated because we've got a 1 in here. So we've got a mixed number, we've got we've got a whole number and a fraction. So, first thing we want to do is make that a top-heavy fraction. Okay, so 1 and 5/6. That's 1 whole and 5/6. Now, if you imagine what that looks like, that's I've got one whole bit of pizza, and then I've got a pizza, and let's see if I can cut this into 6. 6 is a wee bit tricky. There's 6. Okay, so I've got 1 and I've got 5/6. Okay, so I've got 1, 2, 3, 4, 5/6. All right, this bit is nothing. We're not using this bit in here. Okay, so 1 could also be broken up into 6. How many 6 are there? 1, 2, 3, 4, 5, 6. Okay, so 1 is equal to 6/6. It's also equal to 4/4s or 4/4, 5/5, 7/7, etc. Okay, so I've got my 6/6 and I've got 5/6. I can add them together, and that's 11/6. So graphically, that's how you would do it. In simple maths, all you're really doing is saying 6 times 1 plus 5. Okay, but if you think about it, that's what we're doing with the imagine pizzas for the wholes. Okay, so 11/6. 11/6 divided by 3/4. Okay, and for this one, we're going to use KFC. Okay, we're going to keep it, we're going to flip it, and then we're going to change it. Oh, I've written C twice, but you get the point. Okay, so we keep this one the same to begin with. So that stays 11/6. We flip the second term, so that becomes 4/3, and we change the sign in the middle to multiplication. Okay, KFC, keep, flip, change. Now, at this point, it would be sensible to make our life easier for ourselves and simplify. So, can 11 and 3 simplify? No, there's not a common factor there, is there? But 4 and 6 can. Okay, we can divide both of these by 2. So I divide this by 2, I'm going to get 2. Divide 6 by 2, I'm going to get 3. Okay, that's going to give me 22 divided by 9. I could rewrite that, so that would be 9 and 18, so that's 2 wholes, 18 and 4/9. Okay, now let me just see. Pen. Okay, so the marking scheme says you're getting a mark for this point here and then your final answer. Okay. Now I would just like to a word of caution on this, just point this out. when we have come to simplify this, we simplified at a multiplication stage. Okay, you cannot simplify at this stage. So if you wanted to simplify the 6 and the 3 here, that'd be wrong. Do not simplify at this stage. Okay, if you simplified at that stage, let's think that would become 1, that would become 3, that'd be 44. Let's just think, actually, I'll put it down. Oh, I'll write it just quickly up here. So that'll give you 11 divided by 2, and that'd be 1 over 4. So keep that the same, flip that. So that'll give you 44 over 2. So that'll give you 22 as an answer. Okay, and we got 22 over 9, so they're very different answers. Now, do we think 22 seems like a reasonable answer? Or do we think that 2 and almost a half seems like a reasonable answer? Definitely 2.5. If you think what we've done, we've said 1 and 5, 6. Now let's just say that's almost 2, isn't it? That's almost 2, let's call it pizzas, right? For me, fractions are always pizzas. So 1 and 5, 6 is basically 2. So I've said 2 pizzas divided into 3 quarters. So one pizza, there's a 3/4 in one pizza, and there's a 3/4 in another pizza, and then we've got 2 quarters left, which would almost be, 3/4. So it's definitely 2 and something. It's kind of like 2.5-ish. Okay, it's that kind of number. So I'd be looking at this number and thinking, yeah, I'm quite happy with that. 2 divided by 3/4 is roughly, 2.5. It's that kind of number. If you did your simplification here and got 22 as an answer, you might think, I'm pretty sure that 3/4 does not go into 22 times. Okay, so just thought that was worth pointing out. All right, I'm just going to get rid of. If I'll just leave it, it's fine. Okay, so that's our fractions. What's that? 7 minutes, loads of time. So yeah, 3 questions in, and we should all be thinking to ourselves now, yeah, this is fine. Fractions are easy, statistics are easy, and substituting is dead easy, okay? And this is the other lovely easy question that you get as well, okay? So multiply and simplify out the brackets. So first thing I'm going to do, what I like to do is draw a little table. Okay, so some people do their FOIL, oops, I thought that was going to be a straight line. Some people like to do FOIL, where it's first the outsides and then the insides or something like that. That's, if that's your method, okay. I personally prefer this, and it's for me, it's more visual, which I quite enjoy. I think it's harder to make a mistake, but I also think it's quite good when you need to do trial and error as well. So yeah, I quite like this way of thinking about it. Okay, so there's the second bracket, and here's the first bracket. So when we multiply 3 terms by 2 terms, we're going to end up with 1, 2, 3, 4, 5, 6 terms. Okay, again, this method works for massive brackets. Okay, when you start doing the inside outside method with bigger brackets, I think it just becomes a wee bit trickier. Okay, so let's get cracking. 2x times x squared, 2x cubed. Okay, so I've just multiplied this top row by 2x. Okay? And again, because I've written x squared, then the x term in the units, and here I've got the x in the units, you see you've got this kind of dissension, you've got the cubic, the square, and the single x. Okay, it just is in a nice order because I've written it down in a nice order. Okay. Yeah, so now, because of the way I've written it, diagonally, we've got similar terms. Okay, so these terms are similar. And so I can change the color. And these terms are similar. So I've expanded it by getting this, and now I'm going to simplify it. So I've got 2x cubed, absolutely, and now I've got 3 minus 8x squared. So that's minus 5x squared. Minus 12 plus 2, minus 10x plus 3. Okay, let's just have a look at the marking scheme. So we're getting marks for 3 marks. Yeah. So we get a mark for starting to expand. So you've kind of got a mark for this first line, mark for the second line, and then a mark for simplifying it all, putting it all together. Okay. Time-wise, I think I'll just stop there. Okay, but try this table method if you've not used it before. I think it is good. It's a nice visual way of representing your multiplications. And actually, just before we finish, this does remind me of our indices as well. So here, x squared times 2x is x cubed, right? Because we're adding the indices. If you imagine actually just having x, it's like there's a little 1 there. Okay, so it's 2 plus 1 because we're multiplying them, gives us 3. So there's a little 1 there. 1 plus 1 gives us 2. So sometimes people get confused when if they see x to the 5 times x to the 6, they sometimes write, oh, it's x to the 30 because they multiply them. But if you were doing this table, you wouldn't say that um, x squared times x, that would give you x cubed, yeah? Something about wrong there. I'll give you x cubed because there's like an x1 there. You would never look at that and say, well, that gives me x squared because 2 times 1. Okay, so sometimes if you forget rules, the point I'm going to make is if you forget rules, try and think of things that you do know and say, well, actually, would this hold true in that case? Okay, so yeah, I'll just rub them out. It was just a little thought on the side about indices. Okay, so thanks very much. Let's crack on. If I can find the stop button.